Hello and welcome back. Today I have a 20-bit programmable digital voltage source, and you can set the voltage. It's kind of a calibrator. You can set the voltage from 0 to 10 volts and a little bit above. It is from a company in Germany and it's called WRYtech. The type number here is PDVS2 Mini, and if you think it looks familiar, let me explain you why. And you can see the 20-bit, it has lots of digits. While I talk, it's all warming up. The multimeters are warming up. We need at least 20 minutes for this. The device comes, of course, with a nice calibration sheet, with the temperature. It has a burn-in time of 250 hours at least, and it is calibrated against the Keithley 2002, which is an 8.5 digit multimeter. The PDVS2 Mini has been around for a while. It was actually born in Scotland. Ian or Ian Scott Johnson around 2018. Before that, he did already a lot of work on this type of devices. Then in 2024, the project was sold to WRYtech, a company in Germany run by Johannes, and with this new energy, little improvements were made. The voltage range was extended a little bit. Instead of going from 0 to 10 volts, you are now able to go from 0 to 10.2222, so a little bit more. There is an internal temperature sensor, so you can see the temperature of the enclosure also, which is just, I think this one is from December. It is the latest version. Instead of the LM399, there is now a possibility to order one with the ADR1399. And the ADR1399 model also has gold-plated connector to make it even better. Here it is. Nice metal box. It is a battery powered 2 times a 9-volt battery. I will go deeper into the batteries later because I did some testing. When we switch it on, we see the nice logo, and well, it just controls very easy. Look at all those digits, and when you want to change something in the back end, we just do that. And as I said, this is the ADR1399. There are 2 versions. One is with the LM399, which is already very good because most of the 6.5 multimeters are equipped with that reference. But now there is also the ADR1399, which is improved. The specifications are a little bit above my head, but let me try to explain anyway. The ADR1399 has a lower dynamic output impedance, and that makes it less sensitive for variations in the supply voltage. I found an example in the datasheet, and they just say, okay, you have 0% variations on your 15 volt supply voltage. That will result on 2.8 microvolt on the LM399, but only 0.22 microvolt, so that's times 10 lower on the ADR1399. The downside of that lower output impedance is that it is more sensitive for capacitive load, and it could cause ringing or oscillating. But that is also easy to minimize by changing the output circuit, what of course is done. Calibration sheet, no secrets here. They just say, okay, we use this meter to calibrate it with that serial number on this temperature, and these are all the values that we measured. And this is the digital analog converter setting, because you can manipulate it yourself if you think you know better. Here are some other voltage settings. This is most important. The battery voltage during calibration was this voltage, and we can see that later in the display. The internal temperature was this temperature, and the burn-in was at least 250 hours. Well, if you look at these numbers, these are very close. And remember, this is done with an 8.5 digit multimeter. So what will it do on my simple 6.5? Well, let's see. The battery is good, 15.5. I have here 15.9, 29 degrees, 27 degrees. My lab temperature is 20 degrees exactly, but in a half hour it will probably be around 21. The device is calibrated horizontal like this, but of course like this we can read it better. But yeah, I really need to put it like this. To minimize the distortion, I will be using this BNC with shielded cables. I set it now to 1 volt, plug it in, and that is very close to 1 volt. And let me see how many, 1, 2, 3, 4, 5 nines. And what I have in my specifications, I have indeed 1, 2, 3, 4, 5, and then 686. Pretty close. 2 volts. Wow. And well, this is just a matter of temperature also, because I think you need to go 22 degrees in the lab, and well, the internal temperature will probably rise a little bit, but that was also 29.3 and I have here 27. 3 volts. Oh yeah, it already comes close. So this is just a matter of temperature. Wow. Cool. 3 volts. 4. 5, 6, 7, 8, 9, 10, and we can even go with it last digits. I will just run this a little bit longer till the temperatures match, but it is super close. The user interface is pretty straightforward. We have the on-off button, we have an OK button, and we have up, down, left, right. So we are immediately in voltage mode, so we can just go up, 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 or like this. It does exactly what you expect. The OK button also brings you to the menu. In the menu you can, for instance, set different things. Up screen, left, right. Okay, what we need to do, we can do calibration, which I absolutely will not touch. The normal settings. Left, we can do the battery low indicator. Shut down, charge on or off, because we can charge. There is a charge plug here, I will show that later. Maximum charge, when do we think it's full. We have a bound rate, there is a serial port here. You can use your Arduino EDA to communicate with it. What type of mode, so how much information it is, I think. And we have save exit or exit no save, which I will do. And up for the main screen. The device runs on 2 9-volt batteries. These standard batteries will probably give you, I don't know, 8 hours or something, or 12 hours, depending on the capacity, of course. But then you need to open it to change the batteries. So you probably want to use rechargeable batteries. The manual says best to use these ABL, and let me explain why. These are lithium or lithium-ion batteries, but it has 2 cells inside, so this 3.7 you have twice. When it's full, it's 4.2, so you will have like 8.4 volts. If you put that in series, you have more than 16 volts, so that is more than enough. The plus side is it has a charge circuit. We have a charge plug here. We saw in the settings you can charge with a maximum of 400 millis. That is a safety feature. It will probably charge below 300. And the good thing is these, because it doesn't have a converter, you can charge directly on the pin, so you don't need to open the device. While when you use this type of rechargeable batteries, these are kind of not that good, to say nicely. The capacity is crazy high. It's a bit weird because it only has a 3.7 lithium-ion battery with a step-up converter. So it will keep the voltage very long at 9 volts, and then it will be completely gone. But because of the step-up converter, it is kind of noisy, and I did a test with that. Let me get a standard battery here, 9 volts, almost new. Well, we can see it drops very fast, and it's just 100 milliamps or 90 milliamps. I'm using a 1 ohm resistor, and this will happen also in the device, and it will go down. So this will take 12 hours, and then it's probably not enough for the device. Then we have this lithium ion without step-up converter. They start a little bit lower, so the first part will go down very quickly, but then it stays stable a long time because of its capacity. That's this. And then you think, yeah, well, maybe I want to use these other ones here. This is with the USB connector, so you cannot charge it in the device. So just like with the normal batteries, you need to open it to charge. And you don't want to open it every time. This one is nicely 9 volt. And even that the internal battery goes down, the step-up converter will just try to compensate for that. But this one doesn't have a step-up converter. This one doesn't have a step-up converter. And let me show you the signal that this produces. And this is what it looks like on the multimeter. I changed some settings. You can see it now a lot better. This is the noise what you get on your power line using these batteries. Look at this, it is pulsing, and that is the step-up converter. You don't want this on your power line. So downside, noisy, and also you need to open the device to charge them. So my advice would be go for these to charge. It comes with this very little plug, but it comes with it, and it's like, I don't know, 20-30 centimeters. I added bananas on the other end, and you can charge it between 18 and 20 volts. So I set my power supply to 19 volts, 300 millis, and well, with the bananas it's very convenient. I set it to a meter and I switch my output on, connect the plug, and it will charge. And we have, and in the display we can see it charging. You can run it while charging, but still the manual tells you not to do it, because even though I know this power supply is very clean, I still could get some little distortion on the line simply here, even though my voltage is good, maybe with my phone or anything, but also the charging circuit produces a little bit of heat, which also rises the temperature. So the best thing is to make sure that your batteries are full and then run it only from batteries. What I like to do now is to have a look at how clean is the signal. I want to compare that to a Chinese calibrator, my LBO2A, which is one of my favorite. I have a DMMcheckPlus, and of course the WRYtech. Let me first start with this one. Let me get it around 5 volts, and then we try to zoom in a bit. Okay, I zoomed in a lot. You can see it slowly adjusting around this 5 volt. But we can see some noise on the signal. But of course, if you zoom in enough, you will always find something. Then we get, this is one of my favorites, the LBO2. That one is a lot less noisy, so let me zoom in on that. We can see that one is already a lot cleaner. Let's get the DMMcheckPlus. That is even more clean. Look at that. So here we have the random Chinese. Here we have the LBO2 and here we have the DMMcheckPlus. And now let's get the WRYtech. Here we can see the cleanness of the signal is that the DMMcheckPlus and the WRYtech are very equally matched. Because if I switch back now to the DMMcheckPlus, so this is probably in your hobby grade, is probably the cleanest you can get. But as a reference again, if we go back, this is the LBO2, which is already very clean, and this is, woof, the other random. Look at that, almost straight clean line. Let me see if I can get some better statistics. Maybe I can. I'm clearing now the buffer. This is the DMMcheckPlus. And let's see what kind of peak to peak or deviations we have. I will run this for a while. Okay, I did more than 5,000 readings, and I will take note of this and compare to the others. Yeah, now I'm checking more than 5,000 meetings. Peak to peak here is 23 micro, and the average is below 3, so it's fractional better than the DMMcheckPlus, what we also expect for its price, but also I'm using here a better cable, which I'm not able to do with this one. Let me check the others as well. There is indeed a difference. We are close to 5,000 readings again, but instead of being around 25 or 30 microvolts, this one is really like 300 with an average of 90 and a bit instead of 3 that the others do. Well, this one we can already see jumping a lot. I'll reset again, but clearly this is something different here. When we look at the cleanliness, we could already see graphical that the Chinese calibrator was a bit more noisy, even though it was still within the specifications. Then we saw that the LBO2 was very nice, but we see there that the deviation was, the peak was about 300 microvolts, and the deviation was about 90. Well, clearly the shootout was about the last two, the DMMcheckPlus and the WRYtech. The WRYtech was just a little bit better. If we look at the peak, it was like 25 for the DMMcheckPlus and in the like 22 on the WRYtech, and also with the standard deviation was for the DMMcheckPlus was just above 3 microvolts, which is pretty good. But for the WRYtech it was even below the 3 microvolt. I did a test with 5,000 samples and with 10,000 samples. I tried with a little bit higher impedance and a bit lower, so like the automatic mode should give me 1 gig or 10 gig, and with the standard 10M, but they didn't change the values. The temperature, it's been on now I think for 2 hours. It is inside is 29.1 and the calibration was done at 29.3, so that is good. The lab has gotten warm and we are around 24. It's actually a little bit high, but let's see what the values do now. Let's go down to 1 volt. It is fractional low, but we saw the same on the calibration. Then the 2 volts. Yeah. 3. Very close. 4. I don't think it changed that much between half an hour and these 2 hours. So that is actually pretty good. 7, 8, 9, 10. I really wanted to show you that it would say 10.0000 because it did say that last month when I was playing with it, but apparently something is different in the lab, or the temperature is just different, or the meter, something is different, but this is as close as I have ever seen on this multimeter. We probably want to have a little look inside. Well, after the screws are out, you can just remove the front, and then we can open it. It is a nice steel enclosure or aluminium, but it is nicely painted black. It is PCB, it is black. We can see the brand, the buttons, gold plated plugs. We have here some caps on the connection. It seems to be kind of isolated here, which is good. The batteries easy go in and out with these type of clips, which is nice. So there is not too much to see because the battery cover will just cover up everything. This seems to be the charge circuit, and I think the LM or the ADR in this case is underneath the display in this housing. So they made some sort of protective housing, also that there is no draft around the chip there, the reference. So there is not too much to see, but it looks pretty well made. I like these isolation strips. This is, by the way, the communication module that you can order. It is again completely isolated, probably some sort of opto, and it's TTL to USB, so you can communicate with the device. Also nicely branded. It looks good. So this device clearly comes very close to a low voltage calibrator. At least it just blows away those simple process calibrators. And I'm actually very pleased with this. It was not a sponsored video. I bought it for myself as a Christmas present. So thank you for watching, and I hope to see you next time.